Hi folks, I'm Miss Barker and today we're going to be looking at how to do those tricky Nat5 titration questions. So first off, let's remember what a titration is. You can see we have our conical flask and we're going to put 20 centimeters cubed of vinegar into it. Remember vinegar's real name's ethanoic acid. Also, don't forget that we need to add an indicator in there as well. Next, we set up our burette and fill it up so that the meniscus, that's the bottom of that little dip, is on the 0, and we're filling it with 0.5 mole per litre sodium hydroxide. The 0.5 mole per litre is the concentration of our hydroxide. This is an example of an acid-base titration, as the acid is the vinegar and we're neutralising it with sodium hydroxide, which is a base. So let's do our titration. Open the tap, swirl the flask, and there we go. The indicator has changed colour from colourless to purple. This means we've fully neutralised the acid. As you can see, it's taken us 25.3 centimetres cubed of the sodium hydroxide to neutralise our vinegar. But now, how do we work out the concentration of the vinegar? Firstly, let's remind ourselves of one of our super helpful triangles. Here you can see we have N, which stands for number of moles, V, which is volume in litres, that's important to remember, and C, which is our concentration, with the units moles per litre for that. But we now need to know how to use the triangles. Don't worry though, I'll show you. Firstly, before we do our calculation, we need to write a balanced equation for the reaction. So we have sodium hydroxide reacting with ethanoic acid, vinegar. Because it's neutralisation reaction, we produce a salt and water. So in chemical formula, that's NaOH plus CH3COOH, which is the formula for ethanoic acid. We then take the OH from the hydroxide and the H from the acid to make water, and combine the remaining formula to get the formula of our salt. And let's do a quick check. Yes, that equation's balanced. Let's start the calculation. The important part of the equation is just this first bit, because we're looking at just the sodium hydroxide and the acid. We're going to be able to do this in the format of a table, and this is going to help us keep track of the calculations we're doing. So let's start by putting in a row for concentration, because we know this value for sodium hydroxide, and this is what we're trying to find out for the vinegar. Let's just put a box there ready and the units too. Next line, we know the volume for both solutions, so that's 25.3 centimetres cubed and 20 centimetres cubed. Now let's pause. Remember I said earlier about the units of volume, it needs to be in litres. So to do that we need to divide each of these numbers by 1,000, because there are 1,000 centimetres cubed in a litre. Fantastic! One final step we need to do is work out a ratio. This is important as we need to know how many acid molecules react with how many base molecules. This is where our equation comes in. As you can see in the equation, there are no numbers in front of either the sodium hydroxide or the vinegar, which means one molecule of the sodium hydroxide reacts with one molecule of vinegar. So the ratio is 1 to 1. Now let's draw our triangle and start calculating. So first, we should fill in the left-hand column of the table, the one for sodium hydroxide. To do that, we need to work out the number of moles of sodium hydroxide that have reacted. As you can see, we need to multiply the concentration with the volume, and that gives us 0.01265 moles. Next, we can now fill in the number of moles of vinegar that have reacted. Because we know that they react in a 1-to-1 ratio, this means that 0.01265 moles of vinegar have also reacted. Final step now is to complete the right-hand side of the table. We have the number of moles of vinegar that have reacted, and we have the volume. So again, using our triangle, we can see that for the concentration, we need to divide the number of moles by the volume, and this is our final answer of 0.63 moles per litre. Now it's your turn. Pause the video on the following question and have a go yourself. In a titration, it takes 14.7 centimetres cubed of 1 mole per litre sodium hydroxide to neutralise 20 centimetres cubed of hydrochloric acid. What is the concentration of the acid? Pause the video now, have a go. Okay, welcome back. Let's see what you've got. So let's use colours again to help us identify what the question tells us. We have 14.7 centimetres cubed of sodium hydroxide at 1 mole per litre concentration, and we have 20 centimetres cubed of hydrochloric acid. Firstly, let's write our balanced equation for the reaction. Now we start building our table, and remember, we're looking for the concentration of the acid. Next, we can fill out our volume, again converting into litres by dividing each number by 1,000. We need to write down our ratio, and hopefully you've got the same as me. The ratio is 1:1 again. Again, using our triangle, we can do concentration times volume, get the number of moles of sodium hydroxide that have reacted. And then because our ratio is 1:1, we can say the number of moles of hydrochloric acid reacted is also 0.0147 moles. And again, finally, using our triangles to help us work out what calculation we need to do to get a concentration, we have to do the number of moles divided by the volume to give us 0.74 moles per litre. So I have one final challenge for you. Shop vinegar has a concentration of 0.9 moles per litre. What volume of 0.5 mole per litre sodium hydroxide will it take to neutralise 50 centimetres cubed of the vinegar? Okay, let's get our colours out again. The question tells us that vinegar has a concentration of 0.9 moles per litre. You can see I forgot to underline it, but it also tells us we have 50 centimetres cubed of the vinegar. However, it also tells us that this time we're trying to find out the volume of sodium hydroxide, and tells us also its concentration is 0.5 moles per litre. So this time we're looking for volume. So, starting off the same way, writing our balanced equation. This time though, volume is going to be our first line, because that's what we're looking for. You can keep the layout the same as before, but I find it easier to put the thing I'm looking for on the top row. And we can fill out the volume of vinegar, making sure to convert it to litres. Next, we have our concentrations, and once again our ratio. Now this time, we're going to fill out the vinegar side because we have all of the information we need to calculate the number of moles of vinegar that have reacted. Again, it's a 1:1 ratio, so we now know that the number of moles of sodium hydroxide we reacted was 0.045 moles. This time, when we use the triangle, it's slightly different because we want volume, so we need to divide the number of moles by the concentration. This gives us 0.09 litres. Yes, litres. Remember those pesky units. We have taken the concentration, which is moles per litre, so currently the units are in litres. So for a final step, we need to remember to convert back to centimetres cubed, and this time multiply 0.09 by 1,000 to get 90 centimetres cubed. Hooray! So that's today's video. Well done for making it through. Titration questions can seem tricky, but with a bit of practice, I know you can get the hang of them. See you next time!